Hello students, welcome to Educate. In the last class, we have discussed about the nomenclature and isomerism in alcohol, phenols and ethers. Now we will discuss about the structure. We will discuss about the structure of functional groups, that is in alcohol, phenols and ether. Now let's see about this one. No need to mug up the bond length and bond angle. This one here. But here in bond length, bond angle, you should keep here that bond angle between COH will be 108.9 degree. In tetrahedral geometry, a bond angle are 109.5 degree. But here bond angle will be 108.9 degree by the two lone pair of electron present on the oxygen. The two lone pair of electron present on the oxygen that will repel here. So bond angle will tilted here and that will not remain 180 degree. If there be no lone pair of electron on the oxygen, then bond angle would be 180 degree. But the two lone pair of electron present on the oxygen, that will decrease their bond angle. And bond length here, carbon oxygen bond length 142 picometer. 1 picometer is 10 power minus 12 meter. You already know 1 picometer is 10 to the power minus 1 picometer is equal to 10 to the power minus 12 meter. In case of here phenol, what happened? There will be meager increment in the bond angle and that become 109.9 degree. Bond angle, since there is partial double bond characteristic between carbon of benzene and of the oxygen, there will be partial double bond characteristic. So that's why the bond length here will decrease through 6 picometer. So bond length in case of alcohol, CO bond length in case of alcohol is 142 picometer. So in case of phenol, the bond length will decrease through 6 picometer and that become 136 picometer. Due to the partial double bond characteristic, this bond will come closer. So there will be shortening of the bond between the carbon and oxygen. In case of ether, bond length approximately same as that of the alcohol. CO bond length will be approximately same. That means meager decline. That will be 141 picometer. And bond angle here is 109 degree. So then after bond angle decreased by 2.7 degree. That is here, and this is the informative concepts, and here these questions don't ask frequently in the examination. Then after is alcohols and phenols. Then after we will discuss about the preparation of alcohols. Okay, there is mechanism also in this chapter. There is 3 mechanisms from which one questions asks in the examination of 12th board. So we will discuss about the mechanism separately. So firstly, we will just go through the reactions, that means chemical method of preparation of alcohol. So let's see, first one is by acid catalyzed hydration. Acid catalyzed hydration means addition of water. Hydration means addition of water. Hydration means addition of water. And dehydration means removal of water. You know already, maybe in your day-to-day life, you might be aware, some persons feel the problem of dehydration. That means from that persons, the water lost fastly. There is hydration and dehydration. Make a difference. One is hydrogenation. Hydrogenation means addition of hydrogen. And dehydrogenation Dehydrogenation means removal of water. Oh, sorry, removal of hydrogen. If you get confused in the examination or anywhere, anytime, hydration and hydrogenation. So here, full term of hydrogen has been mentioned. So that's why hydrogenation. Fully hydrogen has been written. And here hydration means water. Okay. Now let's see what about the reactions here. I shall tell you something in detail about these reactions. Let's see here. Something I shall take different compound. This compound, when you react with dilute H2SO4, dilute H2SO4. Dilute H2SO4 means there will be high amount of water and H2SO4 you will have to take. Here the H2SO4 will act as catalyst. So what happened? What's the reaction here? Reaction may be in this form also. That is, this one actually water react here and H2SO4 act as catalyst. In the examination, question may be in this form, may be in this form. So here is written dilute H2SO4. So it's understood that the amount of water will be there. Actually, during the reaction, water get added and H2SO4 act as catalyst. So that's why a term is here also. Acid catalyzed hydration means water will get added in presence of acid. Here H2SO4 takes as acid. So what happened here? Actually water participate in the reaction here. Water H that will dissociate to H plus and OH minus ion. Here OH minus ion is the negative part, hydrogen is the positive part. And you know by the Markovnikov's addition rule that during the addition reaction of alkene, the negative part of reagent, during the addition reaction in alkene, the negative part of reagent will bond to that unsaturated carbon atom, which will contain less number of hydrogen atom. Or during addition reaction of unsaturated hydrocarbon, the negative part of reagent will bond to that unsaturated carbon atom, which will contain less number of hydrogen atom. So here is OH minus, this one is the negative part. So that may, and here this carbon is unsaturated and this carbon is unsaturated, out of which this carbon is containing 2 hydrogen and this carbon is containing 1 hydrogen. So that's why OH will come to this carbon, OH will bond to this carbon and hydrogen will bond to this carbon. So compound will become this one. So same here, when alkene react with dilute H2SO4, there will be formation of water. OH will bond to this carbon and hydrogen to this carbon. Actually water is reacting here. Okay, so keep in the mind in the examination, if there will be dilute H2SO4, so don't try to directly add this one H2SO4. Here H2SO4 is acting as a catalyst, provided that if there be written dilute. Okay, now let's see about the mechanism. I shall discuss later on, because together when we will discuss, then you will feel more easy to understand this one. Now next point is by hydroboration oxidation. Next method of preparation is hydroboration oxidation. Means hydroboration means borane B2H6 is diborane, BH3 is borane, BH3 is called borane, and it's doubling of that dimer of this borane, that is B2H6, that is called diborane. Let's the structure of diborane. In diborane there will be here this boron, here hydrogen, hydrogen. To one boron, the 2 hydrogen atoms will be covalently bonded, and to the other boron also the 2 hydrogen atoms will be bonded. Now to one hydrogen, this one and this one will be, that means with one hydrogen this boron will be also bonded and this boron will be also bonded. This hydrogen, this boron, they will lie in a single plane. and this boron will be about to that plane, and this hydrogen will be also about to that plane. Through this hydrogen also, this boron as well as this boron both will be bonded. This type of bonding is called banana bonding. Banana bonding. So banana bonding happen in case of diboron. This one is diboron. Now let's see how to write the structure reaction. Here it is B2H6, that is here. So here BH3 actually, that's double. What happened here? The hydrogen go to this carbon and this BH2 goes to this carbon. So that's here hydrogen BH2. Now again the other alkene molecules, there will be a number of alkene. Here a number of alkene will be there which will react with diboron. So in this compound also, again here of this BH2, one hydrogen will bond to this carbon and this carbon with to boron. So one hydrogen released from there, that become BH here, and the two alkyl group, this one here, this one, and like that when hydrogen will bond to this side, that will also become CH3, CH2, CH2. So that will get bonded to boron. So that's why this compound form. Then after again alkene will react. So this hydrogen will also go. This hydrogen will bond to this carbon. This will also become CH3, CH2, CH2, CH3, CH2, CH2. So valency of this carbon atom become destabilized. So that will bond to this boron. So that's form. Now here then after when water or peroxide will be passed or alkali will be passed, so there will be abundance of OH minus ion. So these OH minus ion, here is 3 parts of alkyl, 3 alkyl group. So the 3 OH will combine with 3 alkyl group. So there will be formation of 3 alcohol and the 3 OH will combine to boron. So that become BOH whole thrice. BOH whole thrice, the structure will be like that. It is called hydroboric acid. This compound is called here BOH whole thrice. Don't we consider this one as alcohol, this one as a base. It is acid. It is hydroboric acid. This compound is called hydroboric acid. Okay? And this one is also not a protic acid. BOH whole thrice, that's also not a protic acid. It acts as an acid because the octet of boron is not complete. Okay guys? Now let's see. Next question. Next method of preparation by carboxyl compounds. What happened here? Carbonyl compound, aldehyde, ketone and carboxylic acid. They are called carbonyl compound. The aldehyde, ketone and carboxylic acid are called carbonyl compound. How to react? How to prepare? What happened here? Aldehyde is more reactive than ketone. Aldehyde is more reactive than ketone. So that's why aldehyde, direct hydrogenation of aldehyde can take place. That means here in presence of palladium or noble metals, we call that the D block elements. Palladium that provides the surface area to the hydrogen here. The palladium provides surface area to the hydrogen only. So what is structure actually here? I am writing RC double bond OH here. Here hydrogen is like this. The palladium provides surface area to this hydrogen. What happened? This oxygen attack the pi electron, here negative charge, here carbon will have positive charge. So one hydrogen will bond to this oxygen and this hydrogen will bond to this carbon. So when oxygen will take the pi electron, then after the hydrogen will bond to this oxygen and the other hydrogen will bond to this carbon atom. So compound become RCOH here. Already there was one hydrogen and one hydrogen get bonded. So that will be formation of, that means it is RCH2OH. That is in this manner here. But ketone is not so much reactive as aldehyde is. You will study in the next chapter also about the reason. So ketone, okay, I am telling here why. That means R here, C double bond OR. So in this case, actually reactivity is because the oxygen attacks the pi electron. Here the negative charge, here the positive charge. But in ketone, this alkyl group will provide the electron to this carbon and from this side, the electron will provide it to this carbon. So to this carbon, the carbon of functional group or the acylic carbon, that will get the electron from two sides. So the here positive charge on this acylic carbon atom will decrease. When polarity will decrease, then obviously reactivity will decrease. In case of aldehyde, there is only one alkyl group attached to this acylic carbon. So this oxygen attracts the pi electron, here negative charge, here positive charge. So only one alkyl group will provide the electron to this carbon atom. So here the carbon will provide from two sides, and in this case, in case of aldehyde, the electron will provided from only one side. So basically aldehyde is more polar than ketone. When aldehyde will be more polar than ketone, so aldehyde will be more reactive than ketone, and that's the reason aldehyde also reacts with hydrogen in presence of noble metals, platinum, palladium, nickel, whatever you would like to take. In this reaction, that's palladium has been taken, platinum, palladium, nickel, any noble metals you can take, because the role of these noble metals is only to provide surface area to the hydrogen. So this compound form. In ketone, what happened? NaBH4, it is called sodium borohydride. NaBH4, that is called so this NaBH4, that is a strong reducing agent. It provides nascent hydrogen. So actually reaction is because this one here ketone, here nascent hydrogen will be provided. The nascent hydrogen will be provided by the NaBH4, that means sodium borohydride. So what happened? Hydrogen will bond to this oxygen and some hydrogen will bond to this carbon. So compound will be RC, here R and here OH and hydrogen. So that can be written as RCHOH, this like this. Okay guys, very easy it is. Now next reaction here, LiAlH4. When carboxylic acid, because carboxylic acid, I have taught you that when hydrocarbon will be treated with mild oxidizing agent, then firstly that will oxidize to form alcohol. When alcohol will get oxidized, that will form aldehyde or ketone. The 1 degree aldehyde will form 1 degree alcohol will form aldehyde, and the 2 degree alcohol will form ketone. And when the aldehyde and ketone both will get oxidized, there will be formation of carboxylic acid. But here aldehyde will react easily, while the ketone will react under vigorous condition. So when the ketone will react under vigorous condition, there will be cleavage of carbon-carbon bond at some places. About that we will discuss in the next class. So when you will reduce, when you have oxidized, reaction goes in this direction. So when you will reduce, reaction will come in this direction. So carboxylic acid, when that will be treated with reducing agent, a strong reducing agent, so there will be formation of alcohol. So one step to this alcohol. So that's why this one form. That means when carboxylic acid react with the reducing agent LiAlH4, that is called lithium aluminum hydride. So when carboxylic acid react with a strong reducing agent lithium aluminum hydride, there will be formation of alcohol. Okay. Now this about this process. Listen. What is that? So in this one here, LiAlH4, that is lithium aluminum hydride, is very costly. Lithium, you know, very costly, which is used in a battery. So lithium battery, very costly. So here same. So obviously lithium aluminum hydride will be highly costly. So since the lithium aluminum hydride is costly, that's why to prepare the alcohol from carboxylic acid, firstly the carboxylic acid will be converted into ester. Firstly the carboxylic acid will be converted into ester by reacting the carboxylic acid with alcohol, and then after the ester so formed will be hydrolyzed, that means will be hydrogenated. Then after the hydrogen gas will pass through the ester, so the ester will get hydrogenated, and then after there will be formation of alcohol and 2 moles of alcohol. How? Let's see here. Suppose a carboxylic acid you have this carboxylic acid you have. So this carboxylic acid, that is 1, 2, 3, 4, 5, pentanoic acid. Pentanoic acid you just react with ethanol. How the reaction takes place? When carboxylic acid react with alcohol, then the hydrogen of alcohol combined with OH of carboxylic acid and form H2O. When carboxylic acid reacts with alcohol, there will be formation of ester in which the OH part of carboxylic acid, will combine with hydrogen of alcohol. So as a result, the valency of this acylic carbon atom become destabilized and that of this oxygen atom will also destabilize. The valency of this acylic carbon atom destabilized and that of this oxygen unstabilized. So this oxygen will get bound to this carbon. Here H2O formed. So this H2O formed here. Now let's see here. What is that? 5 carbon chain. C double bond here, and that will be bonded to this oxygen. So here oxygen, this oxygen is bonded to CH2 and then after CH3. So here CH2 and here CH3. This ester form. Think what would be the IUPAC name of this compound? What would be the IUPAC name of this ester formed during this reaction? So listen, this oxygen here is C double bond O, this one COO. So this side there is no acylic carbon atom and this side there is acylic carbon atom. Not based on the length of the carbon chain, as in case of ether we have named based on the length of the carbon chain here, and if provided that if there was no any functional group. So here this compound here, writing the name of this compound will be not based on the length of the carbon chain. That will be based on that which part is containing acylic carbon atom and which part not. This part is not containing acylic carbon atom. So for that we will write alkyl, and it is ethane. So we will write ethyl. And for this one we write O8. So it is of 5 carbon. So we will write pentanoate. So IUPAC name of this compound is ethyl pentanoate. So firstly, to prepare alcohol from carboxylic acid economically, we will convert the carboxylic acid into ester, and then after we'll pass hydrogen, and then after we'll pass the hydrogen. So hydrogen we will provide here. So hydrogen this side. So what happened during when we will provide hydrogen? So one hydrogen will bond to this oxygen and one hydrogen to this carbon. So compound become here pentanol firstly, pentanol form, and ethanol which you have taken. The ethanol which you have taken here, that will regenerate. This ethanol will regenerate, but the carbopentanoic acid has been converted into pentanol. And then after here, this one hydrogen again react with hydrogen. So you have already studied in the earlier one. This hydrogen will bond to this oxygen and this hydrogen will bond to this carbon. So compound become. So during this reaction, the alcohol which you have taken to convert carboxylic acid into ester, that has been regenerated, and the carboxylic acid converted into the alcohol. As you have taken the carboxylic acid of 5 carbon, so alcohol will form of 5 carbon, and to convert the pentanoic acid, you have taken ethanol. So ethanol has been regenerated. So the alcohol which you have taken, that will regenerate, and the carboxylic acid will convert into their corresponding alcohol. That was from the carbonyl compound. Then after, let's see. From Grignard reagent. Grignard reagent, a very important reagent used in the organic chemistry. the Grignard reagent. By the Grignard reagent, you could prepare a number of, by the Grignard reagent, you could prepare a number of organic compounds. As for example, let's see here. When you take aldehyde, firstly I have taken here formaldehyde, or that is called methanol. This aldehyde, a Grignard reagent I am taking ethyl magnesium bromide. So this compound. So how the reaction will take place? This oxygen here will take pi electron towards itself, so negative charge. This carbon will have positive charge. Bonding between this carbon and magnesium is covalent. So from here the bond will dissociate. So magnesium will go to the negative side and this carbon will be positive. Among this carbon and magnesium, carbon is here negative side and magnesium is the positive side. So magnesium will go to the negative side, that is oxygen, and the carbon will go towards the positive side, that is positively charged carbon, that is acylic carbon. So this carbon will come to this carbon. So structure holds, here is hydrogen, here C, here OMgBr will form, because when magnesium will go there, then along with that bromine will also go. Here is hydrogen and here this CH2 will get bonded, and with that CH2 CH3 is bonded. So this one. After that, when you pass water here, so there will be water will be H plus and OH minus ion. So H plus and OH minus ion there will be. So magnesium will combine with the OH part. So that become Mg, Br and OH. And this hydrogen, so that will combine to this oxygen. So that become here, carbon here, already oxygen was there. With that oxygen, hydrogen will get bonded. Here hydrogen, and here. So when you have taken methanol, there is formation of here. So length of this carbon chain and the acylic carbon atom, but that will get added. So this compound form. You can, if you will take ethanol, that means methanol, that will give 1 degree alcohol. The methanol will give 1 degree alcohol. In the same way, take another example. Watch out which I am writing. So methanol you have taken, now take ethanol. Here propanol I am taking. This propanol, that's react with ethyl magnesium bromide, same. Initially there will be not traces of water, so you will have to take dry ether. Same, the oxygen will take pi electron towards itself, so that will acquire negative charge. The carbon will acquire positive charge. In this Grignard reagent, there is covalent bonding between carbon and magnesium. So bond will dissociate from here, in which magnesium is a metal. So it will acquire the positive charge and carbon will acquire negative charge. So magnesium will go towards the negative side, that is oxygen, and carbon, this carbon will go towards this carbon of acylic. So this carbon will goes to the acylic carbon. So compound will become this compound, and then after pass water. So water, there will be H plus and OH minus. So magnesium is the positive metal, so that will obviously combine with negative part, that means OH minus, and this carbon, so oxygen will have negative charge. So this, when this oxygen will have negative charge, so H plus will bond to this oxygen. So compound become so methanol have given 1 degree alcohol. The aldehyde other than methanol, that will give here 2 degree alcohol. And about the ketone, that will give 3 degree alcohol. How? Let's watch out here. So now ketone here, it is propanol I have taken, that react with same ethyl magnesium bromide. Same process. As I did the reactions here, in the same process, this reaction will also take place. So oxygen here will take electron, here negative charge, this carbon will have positive charge. Here there is covalent bonding between carbon and magnesium. So bond will dissociate from here. Magnesium is the positive part and carbon is the negative part. So that's why magnesium will go towards this oxygen and this carbon will go towards this carbon. So compound become, so along with magnesium, bromide ion will also go there. So compound become here. Then after pass water, so water will dissociate to H plus and OH minus ion. So OH minus ion will bound to magnesium. So that will become, and this H plus will combine to this carbon. So what's the structure here? There is CH3, C, CH3. So here CH3, C, CH3 here. To this oxygen, the hydrogen is get bonded. So this one, and already this carbon is bonded to this ethyl part also. So here ethyl part. So here is 3-degree alcohol. So we have seen that the methanol will give 1-degree alcohol. The aldehyde other than methanol will give secondary alcohol, while the ketone will give tertiary alcohol. The methanol on treatment with Grignard reagent, the methanol will give 1-degree alcohol. The aldehyde other than methanol will give 2-degree alcohol, while the ketone will give 3-degree alcohol. So that's point right. Guys, same type, that means as where that which part of the reagent will go where. If you will consider about that, then very easily you could predict what would be the product. So like this one here, but keep in the mind here, what is about the Grignard reagent, 1-degree alcohol. If methanol will be treated, there will be a formation of 1-degree alcohol. When aldehyde other than methanol will be treated with Grignard reagent, there will be a formation of 2-degree alcohol. And when the ketone will be treated with Grignard reagent, there will be a formation of 3-degree alcohol. How you have seen. Better if you will practice, then if you will practice this reaction, then you will feel enjoyment also. So I suggest you to practice also. Now let's see next point about this question. Should I discuss? Okay, firstly I discuss about the preparation of phenols. Then after we comes here about those questions. Now let's see here. Firstly, from haloarine. This reaction you are already aware. We have discussed in haloalkane and haloarine. Now about this reaction, benzene and this compound. Oleum is what? Oleum. When SO3 will dissolve in H2SO4, then the compound formed will be called oleum. or when the two sulfuric acid will combine together, there will be formation of oleum. Usually oleum forms by dissolving the SO3 gas in H2SO4. That is, SO3 gas when dissolved in H2SO4, that is sulfuric acid, there is formation of oleum. And what's the structure of oleum? Let's see. A structure, and about this one also, I am telling you about the reactions. Here is this one benzene. So at every carbon atom there will be a hydrogen. A structure of oleum is actually how formed the two sulfuric acid combined together, like this sulfuric acid and another sulfuric acid here. When there be condensation reaction between both of them, so this combined, so there will be formation of, through this oxygen, this sulfur already bonded, this sulfur will also get bonded. So in the oleum, this SO3, SO2 and this SO2, that means this HSO3, that will be bonded through this oxygen. That is oleum. And how is oleum usually prepared? By dissolving SO3 in H2SO4. That's usually oleum form, H2O7. Okay, that is oleum. So how the reaction is taking place here? When that's react with NaOH, then hydrogen of anyone that will combine to this oxygen. So from here bond will dissociate. This become H2SO4. So this become H2SO4. And this SO3H, this sulfur will be bonded to this carbon. How to write the IUPAC name of this compound? Yeah, how to write the IUPAC name of this compound? So SO3 is sulfite, SO4 is sulfate, SO3 is sulfite. So this one will be sulfite, and to this sulfite, one side there is hydrogen and another side is benzene. So its name will be benzene hydrogen sulfite. And that is, and when then after we treated with NaOH. So this NaOH of this compound here, H2SO3, this one, this H will combine with this compound here. So there will be formation of NaHSO3. So sodium of, when NaOH will be taken, when NaOH will take here, then sodium will combine with this HSO3. So there will be formation of NaHSO3, and OH part from here that will combine to the benzene, and there will be formation of phenol. So how we have to prepare the phenol from the benzene? The benzene was treated with H2O7, that is oleum. Benzene has been treated with oleum, that is H2O7. So of that benzene, one hydrogen get combined to the oxygen, through which the two sulfur was bonded. So one part converted into H2SO4 and SO3H will get bonded to the benzene. That form. Then after that will be treated with NaOH. So sodium will combine with HSO3. Sodium will combine with hydrogen sulfite and form NaHSO3, that is sodium hydrogen sulfite. And the OH part of sodium, NaOH, that will combine with benzene, and there will be formation of phenol. Okay guys, very easy. Now next, let's proceed. About this reaction you have already studied, that when the aniline reacts with NaNO2, that is sodium nitrite, when aniline will react with NaNO2 and ConCl, there will be formation of benzene diazonium chloride. That was, you have already studied in the previous chapter. So that is, there is formation of benzene diazoxide chloride. When you have reacted with Cu2Cl2, there was formation of chlorobenzene. But if not, you don't react with Cu2Cl2, you react with water. So what happens when you react with water? So here water is actually H plus and OH minus. So chlorine will bond to this H plus, so form HCl. Then after nitrogen will release from there. So this nitrogen and OH part that will combine to this benzene. So that's form. So benzene is here. Okay guys, easy. Now let's see. Actually in chemistry there will be repetition. So if you will do a smart work instead of hard work, if you will do a smart work, then you could score very well in 12th or in IIT, NEET or in CUET. Very easy, that will be very easily, but provided that you will have to do work smart. Okay, so now let's see here. Cumene is what? Isopropyl. Here it's IPAC name of this compound. The isopropyl group is bonded to the benzene. So its IPAC name will be isopropyl benzene. Isopropyl benzene. So when cumene will be treated with oxygen. So what happened here? Cumene here, oxygen is this one. So this hydrogen combined to this oxygen. So pi bond will break. So valency of this oxygen will become destabilized. And when hydrogen will go from there, so valency of this carbon atom also become destabilized. So this carbon, there will be bond formation between this carbon and this oxygen. So here hydrogen is also. So how the structure will be? So here benzene, carbon here CH3, this CH3, here will be oxygen, this oxygen is bonded to this oxygen, so this oxygen, and this oxygen is bonded to this hydrogen, so this one. How the IPAC name, how to write this name of the compound? Let's see. The compound in which there will be two oxygen atom bonded through single covalent bond, that is called peroxide. So in this compound, this is a peroxide because here the two oxygen atoms are bonded with each other through covalent bond, single covalent bond. In this compound, the two oxygen atoms are bonded with each other through single covalent bond. That's why this is a peroxide. And how to write its name? So to the oxygen, one side is cumene and another side is hydrogen. So that's why its name is cumene hydrogen peroxide. Okay, then after you react with H2O, that means directly with acidic water. When you will react acidic water, so then after what happened here, then in presence of acidic water, this oxygen will come here for the double bond formation, because this compound will be, when there will be single covalent bond between the two oxygen, then that will be highly unstable. When that will be unstable, so the lone pair of electron here present at this oxygen atom, that come here for double bond formation. So double bond will form between these one. So that will be a structure will be this here CH3, here C. So C, that here this oxygen will do double bond formation. So here double bond formation. Now this carbon is also bonded to the methyl. So here is methyl. So there is formation of propanone here, and in addition to that, this OH will get bonded to this carbon. So this OH will when get bonded to this carbon, so there will be formation of phenol. So here for there will be formation of phenol and propanone. So cumene will be treated with firstly oxygen. There will be formation of cumene hydrogen peroxide. Then after the acidic water will pass through the cumene hydrogen peroxide. Then the isopropyl group will convert it to propanone, and the OH will get bonded to the benzene. So there will be formation of phenol and propanone. Guys, that was about the method of preparation of alcohol and phenol. That's completed. Now let's see about these reactions here we discuss. about this question is IUPAC name you will have to write, and this one. What will be the IUPAC name of the reactions? Catalytic reduction of butanol. Butanol is this one. Catalytic reduction means react with hydrogen in presence of catalyst, platinum, palladium, nickel, any noble metals. Then any noble metals will be taken as catalyst, which will provide the surface area to the hydrogen. So one hydrogen will bond to this carbon, one hydrogen to this oxygen. So there will be a formation of butanol. So its IUPAC name will be. Now second question also I am discussing. Yeah, second question. Yeah, that's written here, directly answer. Second question, hydrogen of propene. This is propene. Now you have to react with water in presence of H2SO4. Hydration means you add water in presence of dilute sulfuric acid. So this one, or you can also write in this manner, you can write, or you can also write like this. How the reaction takes place, you already aware that of water, this hydrogen will go to this carbon, because this carbon is unsaturated. This carbon is containing 2 hydrogen, this carbon is containing only 1 hydrogen. So here the number of hydrogen atom is less. So that's why OH part of this water that will combine with this carbon, and the hydrogen will combine to this carbon. So there will be formation of CH3, CHOH, and here CH3. That is, so it is propanol. Third one, C reactions with the Grignard reagent a number of times I have taught. So better, I don't think that anyone could not solve this question. Everyone could solve this question. So you do these questions by yourself. Okay. Now in the next class we will discuss about, that is about the preparation of phenols, and then after, now we will start directly from the physical properties of alcohols and phenols in the next class. Okay. Thank you, Team Educate.